Alright, so this video I want to show the entire computation. So we have in the beginning we have what's called our inputs, right? Which is x1 all the way down to xm, whatever that may be, and that gets inputted to our w transpose x plus b, and we take where this is equal to z, where we take and then where a is going to equal to the sigmoid of z, and then we're going to take the loss of our a compared to our y, which is the actual value. Y is our actual value, and a is our prediction. So this is pretty much what it looks like. This is the forward propagation process. This first, then this, then this. Now we gotta go backwards, right? So instead of forwards, we go backwards. So I'm gonna explain that in a second. Okay. So now our backwards propagation. So I'm gonna start from here. So if we take, like, say the derivative of our loss with respect to our a function. So the derivative of our loss with respect to our a function, that's going to equal to the derivative of w, right? Or sorry, the derivative of a. And sorry, this should be with respect to a. I don't know why I did it like that. So this is the derivative of our a, right? And it should make sense to you, because I hope you're building an intuition, because this layer, this output is dependent on this one. And then we have the derivative of our loss with respect to z, right? And that's z. So if we do, actually I'm going to do this here. If we do the derivative of our loss with respect to z, and remember we're taking the gradient descent, so we're taking two variables, what's it called? Taking the partial derivative. So we're taking two variables derivative. So if we do the derivative of our L with respect to z, which is pretty much just the derivative of z, same thing here. This is just derivative of a. That's going to equal to the derivative of L with respect to a times the derivative of a with respect to z. Right, so this might seem confusing, but again, I hope you are building an intuition. So pretty much, and this is all equal to derivative of z. So if you want to find the derivative of z, right, we need to these. It's dependent on these two. It's dependent on these two, right? Because obviously there's like a line connected to it. And if I draw this, right, x, 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 and then this is our loss, for example, right? These lines, right? It's dependent on those layers. So you're kind of connecting them, if that makes sense. So if we do the derivative of our a, or derivative of our loss with respect to a, and then we do the derivative of a with respect to z, we're kind of connecting them. So then we get the derivative of z. And we use the derivative of a right here to do that computation. So then, and I already did all this, but the derivative of our first variable, w1, which is this one, is going to be just x times the derivative of z. And the derivative of z is equal to all of the derivative of z's stacked up, right? So then that goes on to whatever. And then the derivative of our b, actually I'm just going to say derivative of L with respect to b is just going to be all of the derivative of z's stacked up together. So here we're multiplying every single x by every single z, but here we're just stacking up all the derivative of z's together. So pretty much p sum derivative of z, right? And here we're taking the dot product. So this is dot product. I'm not gonna write the numpy stuff for that. So I hope this can make sense. And also I think I forgot to what's it called? I think, oh wait, no, I did explain that. Okay. So I hope this part kind of makes sense. But again, if you're confused here, like why we're doing x times the derivative of z, I want you to build an intuition, because if we're taking the derivative, if we want to find the derivative of z, right? We already have the derivative of z, and we want to get our w variable's derivative. It makes sense to multiply it by our x, right? And if we want to do it by the b, it makes sense to just multiply it by just it makes sense if we want to get b, it makes sense to just stack up all the z's, because that's not considering x. So when we multiply by x and it's connected to w, it's like something to build intuition with.